Hi, today we'll solve this problem, which basically says that Donald Duck and his nephews sink this ship and they want to make it go up to the surface with ping pong balls with this volume and masses and density of the steel. So the problem is asking us for the buoyant force of the acting on the in one ping pong ball, and the second question is asking us for the number of ping pong balls need to get the ship up to the surface. So what is the buoyant force? We have to recall that the buoyant force is the total weight of the displaced volume, that is the density times the volume times the gravity. And in this case, the density that we'll use is the density of water, since the ship is in water, and the volume is of the balls that are going to get it into the ship, and it will use the gravity. So for calculating the buoyant force acting in only one ping pong ball is quite easy, because we already have the volume of the ping ball, and we'll use the density of water, which is 1000 kilograms per meters cubed, and we'll use the gravity of 9.81. And we only have to replace the values in our equation, and we'll get 0.3286 newtons, since it's a force. Ta-da! And that's how we finish our first question. Second question. So we know that the forces acting on the boat are the buoyant force and also its weight, but also its weight will have to take into account the weight of the ship and also the weight of the balls. So from here it's okay, but how we can know the number of balls that are necessary to fill the boat to get it into the surface? So we have to add another term called m, that means the number of ping balls that we need. So now we have to complete our equation. The buoyant force divides into the buoyant force of the balls and the buoyant force acting on the ship. So we have to add that the number of ping balls times the buoyant force of one single ping ball plus the buoyant force acting on the ship. That is the volume of the ship. And that is equal to the mass that we already talked about, that is the total mass, times the gravity. So it's the mass of the ship times the mass of the balls times n. And that we only have to isolate it. Ta-da! Only one thing is missing, the volume of the ship, but since they are giving us the density and the mass of the ship, we only have to isolate that from our formula of density. And you'll get that the volume. And we'll get a total of 127,373 ping ball, making Donald happy because he can manage to unsink the ship.